G'day students. In this video we're going to look at a somewhat more complicated quadratic equation, and what we're going to do is fill in a table of values for this more complicated equation, and then once we do that we'll plot those points on the graph and then draw the graph of that quadratic function. Finally, we'll then identify the important points on the quadratic function. Now, my suggestion for these, unless you're exceptionally good at integers, is probably use a calculator to help you do this. So I'll bring my calculator up. Quick reminder, if you're squaring a negative number, you must put the negative number into brackets. So negative 3 squared minus 2 times, this doesn't have to be in brackets, but I think for consistency, excuse me, I'll put it into brackets, and subtract 3. Always double check. Okay, x squared, take 2 times x, take 3. Yep, that matches, and click on equals, and that comes out to be 12. So we'll go ahead and when x is negative 3, fill in the table. When x is negative 3, y is 12. Okay, let's have a look at when x is negative 2. So just press the left arrow, change the negative 3 to a negative 2, change the negative 3 to a negative 2, and y is equal to 5. Negative 1. Now let's get into the point where we could do that in our heads, I think, but let's use the calculator for consistency, just to practice if nothing else. Okay, so negative 1, negative 1, and I get 0. Now when x equals 0, you can always do these in your head. That term goes to 0, that term goes to 0. Y is equal to negative 3. When x equals 1, well, I get 1 minus 2 is negative 1. Take 3, sorry, 1 take 2 is negative 1. Negative 1 take 3 is negative 4. When x equals 2, 2 squared is 4. Minus 4 is 0. 0 subtract negative 3 is negative 3. And 3 squared is 9. 9 minus 6 is 3. 3 minus 3 is 0. So I did the last few in my head. So starting with the equation, we make a table of values. Usually about 7 is sufficient for drawing a quadratic. Sometimes even 5 is enough. Okay, let's go ahead and plot those points. So when x is negative 3, y is 12. When x is negative 2, y is 5. When x is negative 1, y is 0. When x is 0, y is neg 3. When x is 1, y is neg 4. When x is 2, y is neg 3. And when x is 3, y is 0. Okay, join those points up with a nice smoothish curve, like so. Okay, that's not particularly good, but it gives you the basic idea. Notice we have the characteristic shape of a parabola, so it looks like we haven't made any mistakes. Okay, let's go ahead and identify the important points. Well, the vertex, the coordinates of the vertex are just going to be 1, negative 4. The y-intercept is negative 3. And the x-intercepts, you can get it from the table, is negative 1 and 3. It's the two places where y is equal to 0, or from the graph, negative 1 and 3. So for any quadratic equation, you should be able to draw its graph by making a table of values, plotting the points, and joining those up with a smooth curve. Okay, let's try a more complicated equation with bigger numbers. So the equation equals y equals 4x squared take 8x take 5. I'm just going to do the first two using the calculator and then just give you the rest of the answers. So my suggestion is you go through and do those yourself and just check them against my answers just for practice. Okay, so with the first one, 4 times, in brackets, negative 3 squared, subtract 8 times, and I'll stick with the brackets, not required in this case, but for consistency, I'll stick with the brackets. And I think I've got it all typed in correctly, and I get 55. Okay, let's put in negative 2, so we can just use our left arrow, 4 times negative 2 minus 8 times negative 2, take 5, and we get 27. Okay, now I'm not going to do the rest of those. It's just repetitive at this stage, but not a bad idea for you to put those numbers into the equation to practice. So you can stop the video and do that. Once you've done that, or if you're not interested in doing that, oops, there's the rest of the answers. Okay, so all I've done there is just plugged in the value of x into the equation and worked out the corresponding y coordinate. Okay, now what I have to do, notice there's no axes on my grid over here, and that's because in real life you don't start with axes. You start with a rule, you make a table of values, and then you've got to figure out on your piece of graph paper where you're going to put your x and y axes. So in this case, y goes from a maximum of 55 down to a minimum of 9, so that's 64. And x just goes from negative 3 to 3. So the x isn't a problem. I can make each of those squares equal to 1. But in the vertical direction, I've got to make each square equal to a number bigger than 1. And I think I've got enough lines there to actually make each square, the height of each square, represent 5 units. So let's go see if that actually works. So I'll go and get my horizontal line. I'll make it red just because that's there. And that means if I draw the horizontal line here, I'm going to end up, I can go down to negative 10, so that's okay for my smallest number. Put in my vertical line in the middle. And I think that's all I need for that. So there's my x-axis. And there's my y-axis. Okay, let's go. Oh, and then the next thing I have to do is put in the values. 1, 2, 3, 4, neg 1, neg 2, oops, neg 3, neg 4. And vertically, I don't have to mark off every single line, so I'll do every second line. So that one gives me neg 10, 10, 20, 30, 40, and 50. So in real life, the equations that you come up with, often you have to scale your axes in order to fit them onto your piece of graph paper. Okay, let's go ahead and plot the points. I better choose a new color for this. I might go with like a pinky sort of color, I think. Okay, when x is negative 3, y is 55, which is there. When x is negative 2, y is 27, so estimating round about there. When x is negative 1, 7 is about there. When x is 0, it goes down to negative 5. When x is 1, it goes down to negative 9. When x is 2, once again, -5, and f3 is 7. Join the points in a smoothish curve. Once again, I get our basic shape of a quadratic. I could have done that more neatly, but it's a bit hard on this screen. So it looks like we haven't made any mistakes. And let's once again identify the important points. I'll just talk about them this time. I won't write them down. So the minimum value in this case is -9. That's the smallest that y is on the graph. The y-axis, sorry, the y-intercept, excuse me, that's when x equals 0. So the y-intercept is -5. And we'll have to estimate the x-intercepts. It looks like it's going to be round about -0.7 or -0.7 or -0.8, and round about 2.4 or something like that, 2.3. So in this case, we can't give the exact values for x, the x-intercept, sorry, but we can estimate those. You will learn in year 10, by the way, how to find exactly where the graph crosses the x-axis. For now, we can only approximate it. Okay, we'll leave it at that and continue with graphing quadratic functions in the next video.